All right, take a look at that question with Polygon Pizza. There was a polygon, get it? Okay, forget it. Anyway, Polygon Pizza says that each pizza is exactly the same size, and there are two parties. There's Sam's party, and there's Elena's. And at Sam's party, everybody got 2 out of 10 slices. Okay, so the pizza was cut into 10 slices. In Elena's party, everybody got 15 out of 100 slices. Now let's just think about this for a second from what we know about fractions, from those little fraction pieces we had. You're cutting the pizza into 100 pieces. Think about how tiny those pieces must be. Here you cut it out of 10 pieces, not nearly as tiny. So you're getting 2 out of 10 and 15 out of 100. So don't think this is such a great deal, maybe. Okay, we want to compare. We want to know who got more pizza, the people at Sam's party or the people at Elena's party. Now we can compare these as fractions because we know so much about fractions now, but I just want to say something about this power of 10. Remember, this is a power of 10. 10, 100, 1,000, okay, 10,000, blah, 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 so far and so forth. Okay? When you have a denominator that's a power of 10 in a fraction, what we're really talking about is we're talking about decimals. So I want to talk about decimals for a minute. So before I do this, I want to go back and take a look. I know you're not allowed to use a calculator. I'm just using this calculator for a pattern, okay? So I want to do the following questions by calculator, okay? So 7/10, okay? We want to see what that is by calculator. It helps if I knew how to turn this on. Here we go. You probably hit the on button. Okay, 7 divided by 10 is 0.7. Okay, number 2, 4 divided by 10 is 0.4. 3, 11 divided by 100. 11 divided by 100 is 0.11. Almost done. 72 divided by 100. 72 divided by 100 is 0.72. 1 divided by 1,000. 1 divided by 1,000 is 0.001. Okay, and the last one, 341 divided by 1,000 is 0.341. Let's talk about why this might be. Okay, we know decimals are fractions that have denominators of power of 10. But so now let's look at the place value chart for decimals that's in your workbook and on the slide. Okay, so it may be a little small on the slide, but it's definitely clear enough in the workbook. Let me just look at the place values chart. You have the ones place, and then you have the tenths place, and then you have the hundredths place, okay, and then you have the thousandths place. Okay, and that's to the right of the decimal. Okay, to the left of the decimal, you have the ones, the tens, the hundreds, the thousands, like we did earlier. Okay, notice there is no ones place. So everything to the right of the ones place has a THS. Everything to the left does not. Okay, that's how we know it's a decimal value. So notice this, 7/10. The reason this is 7/10 is because I can put a 0 here. That's a 0 in the ones place. And there's the first place after the ones place, which is after the ones place, which is the tenths place. Okay? So I could write this as 0.4, 0 ones, and 4 tenths, because that would be the next place. And here, I could write a 0 here, and this would be tenths, hundredths. That's why it's hundredths. Notice there are many places after the decimal as there are zeros. 1 0, 1 place after the decimal. 1 0, 1 place after the decimal. 2 0, 2 places after the decimal. 2 zeros, 2 places after the decimal. Tenths, hundredths. Okay? 3 zeros, 3 places after that decimal. Again, I can write the 0 in the front to show 0 ones. A lot of people really like the 0 in the front of the decimal. I don't. When I look at decimals and I see zeros, they just kind of, I don't know, they just kind of double in my eyes. So I don't like that 0 in the front, but a lot of people like it. But that's 0 for the ones place, and that's tenths, hundredths, thousandths. And again, same thing here. 0 for the ones place if you'd like. 3 zeros, 3 places. Tenths, hundredths, thousandths. Okay, so that's how that place works. And then you can read about in your workbook about how the chart goes and what goes on there. I'd like to go to some questions. So let's look at the next one, which is write each decimal as a fraction. All right, let's take a look at 4/10. 4/10, and again, if you'd like the 0 in the front, you can. 4/10 is decimal with a 4 because there's the 4/10 place. Okay, and that's how you read it exactly. You just read the number, and then you read the decimal place. So 4/10 because it's in the tenths place. This is obviously a negative 9/100 because that's in the tenths hundredths place. And this is 71/100. Tenths hundredths, 71/100. So this is how you read it, and that's on your chart for you, just to make sure you understand how you read it. You just read the number 9, and then say the place. Tenths, hundredths, 9/100. Let's look at this one. 8, you actually do say 832. Tenths, hundredths, thousandths place. 832 thousandths. That's how you say it. And if you have a negative, of course, you say the negative. And that's all there is to it. All right, let's take a look at this. We want to write each decimal as a fraction. Okay, so we know it's negative 7. And this is the ones place. This is the tenths place. So it's 7/10. And that's all you do. That's all we're asking for. That's it. You're done. Life is nice. All right, here we go. Let's look at this one. This is 9/10 place. And again, notice you can cheat. You can cheat because this is one place after the decimal, 1 0. 2 places after the decimal, 2 zeros. Okay? Let's look at this one. This is 678 tenths, hundredths, thousandths, 10 thousandths. Again, 1, 2, 3, 4 places after the decimal, 4 zeros. We should put this in lowest form. We're not going to do that now. I just wanted, it didn't say to. I just want to take a look at this and make sure you understand how to write them as a fraction. Okay, let's take a look at this one. 877, you just write the number down. 1, 2, 3, tenths, hundredths, thousandths, thousandths, THS, that's, okay, try to say that quick. All right, so 877 over a thousandths, over 1,000. Okay, and that's it. You're done. That's all you do. 1, 2, 3, 3 decimals, 3 zeros. Pretty simple. All right, here we go. Next one. We're going to make them harder. We just have to grow, you know? You have to start with a brick. Then you build the house. We're on the brick. All right. Write the decimal as a fraction or mixed number in simplest form. Awesome. Here we go. 7.89. Do you know if this is going to be a fraction or a mixed number, a proper fraction or mixed number? Think about it. Remember what a mixed number has. It has a whole number part and a fractional part. Well, this has a whole number part, so this is going to be a mixed number. There are 2 ways to do this problem. One way is simply 7/89 over tenths hundredths over 100. That's one way to do it. Another way to do it would be this. I can go 789 over 100. Not 1,000 because there are only 2 places after the decimal point, so I still need 2 zeros. And then guess what? It says fraction or said a fraction or a mixed number in simplest form. Means it wants this as a mixed number, but then I'd have to do the next step and go 100 goes into 789 7 times with 89 left over, and you put that over 100. So I'd get the same answer. Just so you know, you can do this, but be careful. You don't put 3 zeros because there's only 2 places after the decimal. So don't count these digits. Count the digits after the decimal. Tenths, hundredths. Okay? Means the denominator is 100. All right? All right, let's take a look at this. That's what you want to do with the rest of these. You want to write the decimal as a fraction or a mixed number now in simplest form, so you want to reduce it. I'm going to do the first one with you. All right. As we do the first one, you want to think about, is this going to be a mixed number, or is this going to be just a pure proper fraction? Well, there's nothing past the decimal point to the left. That means that this is going to be a pure decimal. Let's see how it looks. 750, tenths, hundredths, thousandths. Again, 3 places after the decimal. Now I can reduce. All right. Ready to reduce? Let's reduce. All right. I'm thinking 50's going on. I'm thinking I wish I knew how many times. Okay. So 50 into 750. 50, 100 is 2. So 15 times, I'm thinking. And this is 20 times. Oh, I can go again. 15 20ths. Divide by 5. Divide, whoops. That's a lot of division signs there going on. Okay, divide by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So that is 3/4. So, oh, look what I could have did right away. Oh, I did 50, but you could have divided by 10 and take that out right away and then did 25. There was so many ways you could have reduced this. I chose that way. Okay, so reduce it any way you want to reduce it. All right, so take a look at 2 and 3 and start them off as I write them down. All right, how far did you get, or were you waiting for me? Don't wait for me. All right. This is going to be a mixed number. I'm going to put the whole number. I think I'd rather do the whole number on the side and do 105, and that's tens, hundreds, thousands. Okay? Here we go. Now I can reduce. What do you want to reduce by? 5, maybe? Let's reduce by 5. 5. So 18 stays 18. 105 divided by 5 is 21. You know how I knew that? Because there are 20 nickels in a dollar. So that's 105, a dollar, like that? Okay, so that's 21 over 1,000, which is 200. 5 into 1,000 is 200. So it's 18 and 21 200ths. Okay, this one, negative. Don't worry about the negative. Just write it down. 4 and 3/10. Oh, I love that one. That one's nice and easy. All right, let me show you an easy way to compare these decimals. Okay, so I'm going to take this number right here, 0.058058, take 0.580, and you know how neat I am. I'll try to line it up so that they're really lined up, but don't count on that. Okay, there's 2 zeros in this number. Okay, 3 zeros in this number. Okay, now what I would do is I would make them all have the same number of zeros. So I'm going to get my other color. Okay, here we go. And this has 3, not same number of zeros, same number of places. Okay, same number of decimal places. This is the numbers, same number of decimal places. So this has 3 decimal places. This has 3 decimal places. This has 4. This has 5. I'm going to make them all have 5 decimal places. Well, I can't just put an arbitrary number in there. I'm going to put a placeholder of 0 there. So I'm going to have to add 2 zeros here. I'm going to have to add 2 zeros here. Now they have 5. 1 0 here. That now has 5. And that already has 5 decimal places. Okay, now let's compare the numbers as if they didn't have a decimal. So this is the number 5,800. Okay, this is the number 58,000. This is the number 58,000. This is the number 58,000. So even though they looked different, we now know that this is the same as this, which is the same as this. Notice what happened here. Here, this was a 0 in the front before the 5. These zeros are all after the number. So it appears that it doesn't matter how many zeros you add after your last digit. Let's take a look why that works. You really need to see the relationship between fractions and decimals. Otherwise, you're going to think math is a whole lot of separate topics not related. Everything is related. Okay, it's kind of pretty cool. It's like an Italian family. Everybody's related. Okay, here we go. So we know that these 3 are exactly the same. I'm going to take these 3. I'm going to write them as a fraction. And I'm going to show you they're really the same fraction. Because if they're the same decimal, they have to be the same fraction. Okay. The only clear way to understand math is to understand the connection and to look for patterns all the time. Math is all about patterns. So 0.580 is really tens, hundreds, thousands. 580 thousandths over 1,000. Okay, now let's reduce that. First thing I would do is divide by 10. That would take out a 0. Divide the top by 10, divide the bottom by 10. That would take out a 0 and would be 58 over 100. Now let's divide by, all right, 2, because I can't think of a bigger number right now. Okay, if we divide by 2, then that's 28, 16, 29. 29 over 50. Okay, if that's 29 over 50, all of these are going to reduce to 29 over 50. Let's take a look. Okay, so 58.5800 is 5800 over tens, hundreds, thousands, 10,000. 10,000ths, sorry. We got my ints. All right, first thing I'm going to do is divide by 100 on the top, 100 on the bottom. When I do that, that will take out 2 zeros. If I divide by 100, that now gives me, oh, you know what? I don't even have to go any further because 58 over 100 obviously reduces to 2950. It's good morning. Already did that. All right. Now let's do the next one. 0.58, 0, 0, 0. Okay, that's 58000 over tens, hundreds, thousands, 10,000, 100,000. So 100 thousandths. First thing I'm going to do is divide by 1,000. There are 3 zeros in 1,000. That'll take off the 3 zeros. And I got 58 over 100, which obviously reduces to 29 over 50. So I don't suggest you do that. I suggest you just add the same number of places to each decimal number, as long as you do it after the number. And that statement is in your workbook. If you take a look, I think it's under helpful hint. It's under key information, sorry. Key information, little key on top, looks kind of cute, and it tells you that. For any decimal, writing zeros after the last digit to the right of the decimal point does not change the value of the number. Okay, so that you have to understand. I could add as many zeros as I want this way, not that way. Okay, not before the decimal. So like I can't go 0.580, I can't add a 0 here because that moves the place value of this number all the way over. So I can add it at the end, not before the first digit. Okay, all right, so let's take a look at the next question. Number 2. This is the whole number 43. This is 43.00. This is 0.43 and 0.043. We're looking at those 4 numbers. Okay, first thing you have to understand is anytime you have a whole number, your decimal is at the end of this number, okay? So it's to the right of the last digit. That's where your decimal truly is. So every number, like the number 1, when I count, the decimal is to the right of it. Number 2, when I count, the decimal is to the right of it, okay? So that's what we know. So I can take this 43, and let's count the number of decimal places. 2, 2, 3. Since this has 3 decimal places, we want to write them all with 3 decimal places. Okay, because we're not going to take away decimal places, we're going to increase the number of decimal places. But we want them all to match, remember. Okay, so we want 3 decimal places. Here we go. So we have 43, there's the decimal, and now 3 decimal places. 1, 2, 3. Okay, then we have this one, 43, it already has 0.00. I just need to include 1 decimal, 1 0 for that decimal place to count as 3. This guy's next, I'm going to line up the decimals, 0.43, we want 3 decimal places, so there's your 3rd decimal place, and then 0.043. Now think about the number without the decimal at all, and you got 43,000, 430, 43. Okay, that's what that looks like. Okay, they're not equivalent to these numbers, but that's the easiest way to compare them. This is just 43. This is really just 43. This is 43 hundredths. This is 43 thousandths. But this is the easiest way to compare them. So that tells me if we want to put the equivalent ones together, those 2 are equivalent. Okay? Now, we've already talked about reading and writing decimals, and this is in your workbook, where we know that to read a decimal, we just say the number, 43, and then say the last place that last digit sits. So 43 tenths hundredths, 43 hundredths, okay? And if you have a whole number, so let's say you have 16.431, this would be 16. I see the decimal, that's and, 16 and. That's why we didn't put and in that first mod we did. Remember we were writing numbers? We didn't put the and in because we said that an and meant something else. Well, the else is this decimal. 16 and 431 thousandths, because it's 10 hundredths thousandths. So that's how you read and write decimals. All right, so let's look at some other problems. Of course, the real purpose of liking decimals a little bit is because money, right? Money would be the real reason. Okay, we're going to write these decimals in standard form. Standard form means they're going to give it to us in words, and we're going to write out the actual number. okay, just like in Mod 1. Good thing it didn't change because that would really make us crazy. All right, so the first one says negative 12 and 7/100ths. And this is in your workbook. Negative 12 and 7/100ths. Tenths, hundredths. So that I have to put the 0 there because I have to have the 7 in the hundredths place. So negative 12 and 7/100ths. Okay, let's try number 2. 83 10,000ths. There's no and, so there's nothing before the decimal. Okay, you might want to put your 0 there. Okay, 83 10,000ths. So 83 has got to be in a 10,000 spot. So let's see what that is. Tenths, hundredths, thousandths, 10,000. So it's the 4th spot. So I need 2 zeros. 10, hundredths, thousandths, 10,000ths. 83 10,000ths. You have to know tenths, hundredths, thousandths, 10,000ths, hundred thousands. No one spot. No ones. Okay, so when working with a number in standard form, you may have to put your zeros here to get everything in the right spot. Okay, and that helpful hint is also when you're working. Okay, so we're going to go back to that challenge question about the polygon pizza. You're at Sam's party and everybody got 2 out of 10 slices. Or Elena's party where everybody got 15 out of 100 slices. And boy, did this look like a good deal. Except remember what we learned yesterday about how small your pieces would be. Because, you know, a pizza is, if you deliver a pizza to my house, Polygon Pizza, and one to your house, we got the same size pizza. But at your house, you're breaking it up into 100 slices. That's pretty small. I'm only breaking mine up into 10 pieces, so my pieces will be bigger. So one thing we could do to compare these is we could just get a common denominator. But because we have just been talking about decimals and the fact that when you have a denominator as that's a power of 10, that's a decimal, I would rather change this to decimals. So we have 2 tenths, which is 0.2. If you want the 0 there, have a party. So that's 2 tenths. And then 15 100ths. So 15 100ths is 0.15. Tenths, hundredths. You want the decimal there, have a party. Now we said we compare them with the same number of decimal places. When I say decimal places, I mean after the decimal, okay, or to the right of the decimal. So there's 1 decimal here, there's 2 there. So I'm going to rewrite this down without the 0 in the front because I don't want the 0 to confuse you. There's 2 here, there's 1 here. I want them both to have the same amount, so I'm going to have to put another 1 here. And now this is 20, this is 15. Well, we know 20 is greater than 15. Is greater than, yeah, okay. Is greater than 15, so you have more pizza at Sam's party. Because think about it, the slices have to be so much bigger. So that takes care of that challenge problem. Okay, we want to insert either the is less than symbol or the is greater than symbol to the next 3 examples. And again, we're going to compare these by making the same number of decimal places. So if you try those, and then we'll check them together. Okay, let's see how you did. So let's take a look here. There are 3 decimal places. Here there are only 2. I'm going to get you going with 3. This is the number, if you think about it, 26,208. This is the number 26,280. So 26,208 is less than 26,280. All right? Let's take a look at this. This is 0.12. This is 0.026. This has got 2 decimal places. This has got 3. So we're going to make sure they all have 3. This is the number really, when I can read it as 120 just to make this easier, this thing easier to do. This has 26, and 120 is greater than 26. Please make sure you understand 0.12 is not equal to, or 12 hundredths is not equal to 120. It just makes it easy to compare when they have the same number of decimal places. Okay? 12 hundredths is 12 hundredths, not 120. Okay? Don't confuse that. All right, let's look here. 0.039, 0.0309. This has 3 decimal places. This has 4. So I'm going to write this with another decimal place. And 0.0309, and this is also negative. So this is negative 390. This is negative 309. Remember, it's negative. So negative. So here, this is really, really, really the smaller number because it's more negative. I owe you more. That's less. So negative This one is less than this one. So the is less than symbol goes here, the is less than symbol goes here, the is greater than symbol goes here. And that's how you compare them. Okay? Now we're going to round decimals. Okay, rounding decimals is a little different, not much, a little different than rounding whole numbers. Let's take a look. There's one thing you got to be very, very, very careful about. So one example, the first example we'll do together, and then I have another example to do together, and then you have a couple to do on your own. The first one is when I write down the procedure for it, and just go step by step. Here we go. 3.065, and we want to round that to the nearest tenth. We're rounding that to the nearest tenth. What we're really asking you is this closer to 3.0 or 3.1? Because it's the nearest tenth. Okay? Here's the deal. The difference between this and the whole numbers is that when you round decimals, whatever place that you want to round to is the last place you must see. So you must see the tenths place in your answer. So I'm going to underline the 0 just like I did before. I'm going to look at the number right next to it, to the right of it. I'm going to ask myself the same question I did in Mod 1. Is this number a 5 or higher? If it is, I'm going to move that up by 1. Okay? But then I'm not going to put in zeros. I am done at that point because the tenths place is the last place I can see. So 3 point. That number's a 6, higher than a 5. Therefore, I have to round that up. So it's 3.1, and that's your answer. Okay? Before you look at the 3 you're going to do in your workbook, I'd like to take a look at this next one. 14.796 to the nearest hundredths. Okay. Here we go. You ready? Hundredths place is the last place you must see. Don't go adding 0 crazy like you did in Mod 1. Here we go. This is the hundredths place. I look at this. I round up. Well, I can't really round the 9, so I have to think of rounding the 79. Add 1 to the 79, it becomes 80, so it becomes 14.80. Now, I know what you're thinking. I don't need that 0. You just said I don't need those zeros. They're the same. They are the same. But when you're rounding, you have no choice because you're trying to be exact. When you're rounding hundredths, you have to have the hundredths place. Okay, you have to do exactly what they say. Exactly what they say. So let's round the next couple. Try those in your workbook, and then we'll look at them together. Okay, let's take a look at these and make sure we round them to the right place. When I said that we need to be exact, I mean we need to do exactly what they tell us to do to round to that place. Because remember, once we round, these are not exact answers. These are rounded estimate answers. Okay, here we go. Let's just make sure you understood that. Hundredths, tenths, hundred. This is the hundredths place. I look at that. It's not a 5 or higher, so I leave that alone. So my answer is 5.89. All right? Let's look at number 2, thousands place. Tenths, hundredths, thousandths. I look at that. That is a 5 or higher. Remember, I have to see that place. I have to see the place they're telling me to round to. Okay? So it's 11.0 instead of 29. It's going to be 30. I have to see the thousands place. Tenths, hundredths, thousandths. Have to see it. Okay? And then finally, the last one, nearest tenth. I have an extra number here just to make sure you understand. I only look at the number next to me. Oops, that's not the... I underlined the wrong number. It's all good. Tenths place, right here. Look at this number. That's not a 5 or higher, so I leave it alone. So nearest tenths is 0.5. So that's how you round numbers. Next time we talk, we'll be talking about adding and subtracting decimals. And you're going to like that because that's money. That's all about money.